Hello, Stats 300. This is Professor Gonzalez, and I would like to go over some of the problems on the interactive side of ALEKS. And I like to show that by having that symbol and also this symbol here, which you would see from the pull-down tab when you're in the interactive ALEKS, and you see this notation when you're looking at the gradebook. Anyhow, these are the interactive questions from ALEKS in section 7.3, and also test number 3, part 2, all have questions that come from the interactive side. So that's what this is right here. Okay, so there's just one question in 7.3 on the interactive side, and here it is. Says the producer of a weight loss pill advertises that people who use the pill lose after 1 week an average mean of 1.85 pounds. Now this with a standard deviation of 0.95 pounds. Now this the producer of weight loss pills. So this is not a study. This is not a survey. This is from the advertiser who is getting this from the population. So this would be the mean from the population would be 1.85. Okay, and also the standard deviation from the population would be 0.95. Okay, continue on. Let's see, 0.95 pounds. In a recent study, okay, that sounds like a study, a survey, a sample of 60 people who used this pill were interviewed. The study revealed that these people lost a mean. Okay, so now we're talking about a study, right? A study of how many people. In fact, maybe what I'll do is I'll try to highlight this by saying, okay, now we're talking sample, right? Talking a sample of 60 people. Now, the study revealed that these people lost a mean. Now, this is the mean from a sample, and so that's why we must call it the sample mean, X bar, and that is 1.68 after 1 week. If the producer's claim is correct, what is the probability? So what is the probability? That's the area under the curve that we're looking for. What's the probability that the mean weight loss after 1 week on this pill for a random sample of 60 people, okay, so there's a random sample of 60 people, will be 1.68 pounds or more. Okay, so these, this is an X bar. These are X bars because they're the means coming from a sample. What's the probability that the mean weight loss coming from this random sample, right? So that means that X bar equals 1.68, and there it is right there, our sample mean. And now we want to know what's the probability that the mean weight loss after 1 week of this on this pill for a random sample of 60 individuals will be more than 1 point. Okay, let's get our visual going here. And the first and foremost, we're really supposed to say, remember, if our sample is greater than 30, we don't care what kind of distribution this comes from, if it's normal or not. If the population has a normal normal distribution, doesn't matter, because if our sample size is greater than 30, we can use, in the sample size, and the sample size is greater than 30, it's actually 60, that means, so we can use the central limit theorem, right? Which is great, because once we can use the central limit theorem for sample means, that's this guy right here, right? That's 7.3, section 7.3. Our sample size is bigger than 30. Well, then we can use the fact that the mean of our sample means is going to be equal to the population mean. Okay, well, that's nice because I can now write that down. The mean of my sample means, is going to be the same thing as my population mean right there. So that is 1.85. Okay, got that. What else do we know? Well, we also know by looking at that formula that the standard deviation of the sample means is just going to be the standard deviation of the population over the square root of the sample size. So we go up here and we've got the standard deviation of the sample means. And because we're using the central limit theorem, is going to be the standard deviation. We might as well use a little color for that. The standard deviation is right there, 0.95. And that is all over the square root of the sample. Okay, so now when you put that in the calculator, you get approximately 0.122644, and that goes forever. Let's round it to 4 decimal places. So we'll say that the standard deviation of the sample means is approximately equal to 0.1226. Okay, so why is that important? Well, we're going to be using that information to get z-scores and everything. But let's see what all this means in a picture, in a graph. I always say a picture is worth 1,000 words, and it is, I think, here. Well, maybe. Let's see. So now, what's my picture? Okay. Basically, why does that thing keep on popping? So we've got this standard normal curve. Because what I'm doing here is I'm taking a look at all these samples, right? Sample is 60, another sample is 60, another sample is 60, another sample is 60, and we're finding the means of each one of those, so they're called the sample means by X bar, and then we're making a distribution out of it. So that's what this is. So then the next thing we want to do is we know that, well, this is the mean of the sample means. Well, that's weird, huh? But that's the mean of all these numbers that we generated and all these means from the samples. Well, this is the mean of those sample means. And that seems like that'd be hard to find, but it's not. Central limit theorem says that is 1.85. 1.85. Now this problem is saying, well, you got this sample mean of 1.68. 1.85 is here, so 1.68 must be to the left of that, like out here. 1.68. What's the probability? What's the probability that the mean weight loss after 1 week on this pill for a random sample of 60, there's our sample means of 60, individuals will be 1.68 pounds or more? Well, that means we need to find the area under that curve, and that'll be the probability that it's going to be there. Okay. So now, once again, we don't have a table for these raw numbers. 1.68 pounds. We don't have a table for that, but we do have a table. If we could convert this to z-scores, we will have a table for that. So what we're going to do is we're going to take that guy and turn it into a z-score. Now, once again, we go down here and we do have a formula for when we're taking sample means. We have a formula for that. That's just going to be the z-score equals our sample mean minus the population mean over the standard deviation of the sample means. Okay. So that's just going to be the sample mean of 1.68, right there, minus the mean of the sample means, also known as the population mean, because remember the population mean and the sample mean are the same thing by the central limit theorem. So this is 1.85. And then we have to divide it by the standard deviation of the sample mean. So this is 0.1226. Okay, and after all that work, up top you get negative 0.17 divided by 0.2, 0.1226. And when we divide that, we get z is equal to negative 1.39. So now we have a z-score. So now we're going to copy this normal distribution, but it will now be a standard normal, so the scale will be different. It will look like this. It should look the same. Of course, I can't draw it perfectly the same, but it is a standard normal, the mean of 0. A z-score way down here at negative 1.39, right? We got that right there. And they want to know the area to the right. And we know that when we look this up on our z-score, that'll give us the area to the left. Let's go ahead and do that. I've been looking these up on the z-scores, and I haven't been on the last couple times because we've done them quite a few times, but let's do it again. Z-score of negative 1.39. Go to the negative 1.39, negative 1.3, negative 1.3, that's this one. And 9, if you look, is the last column. So negative 1.39 in the last column puts us there. So it's going to give us an area of 0.0823. 0.0823. Okay, so just like before, just like always, if we want 0.0823, just like always, if we want to find the area of this shaded region on the right, we have to take 1 minus that green stuff, right? Which leaves us with 0.9177, which happens to be, right, the area. How do I show that that's the answer? That is the answer right there. So the probability is this area to the right, which is 0.9177. Okay, I hope that helped out. Once again, use your formula table, right? Use your our formula sheet rather. If you get the notation down, it really helps things out a lot. And I think that is it for this one. I'm going to go ahead and crack out another one since 7.4 only has one problem on the interactive side, so I'll do that now also. It's getting kind of late, but let's do it. All right, take care. Have a good one. Bye.